Hey, welcome back to Mama Physics. This is example 5. Maybe I'll do example 6 as well. We'll see how time goes. On 6.2 part 1, Newton's law of gravitation, we just did example 3 together. I am going to do example 5 and 6. Hopefully you can have a chance to do example 4 by yourself, in which the answer you should know anyways, okay? So starting with 5, calculate the distance. You have to be above the Earth's surface for the gravitational strength to be half of that experienced by us right now. Okay, so let's draw a picture, of course. So imagine this is the Earth. Once it gets itself loaded. And so we're going to pick a point somewhere here. And we're going to say this is, what is it we want? You want the distance above your surface. So assuming this is the Earth's surface, this is X distance away. Don't forget you still have the radius of the Earth. I'll label as RE for radius of the Earth. And we want the gravitational strength to be 1/2 of the gravity experienced by us right now. So that's going to be, we need the G to be equal to 1/2 9.81 meters per second squared. So that's going to be our G value. So this is a little bit different than the previous example we did because this is looking at gravitational field strength. Gravitational field strength is the gravitational force experienced by a unit mass of 1 kilogram. So to find the gravitational field, that is just Fg experienced by whatever mass that is there, which is your little m. So this simplifies to big G times whatever mass is that's providing the attraction force, which in our case is going to be the Earth. And sure, it's multiplied by the small m, but the small m's are going to cancel out, and that's going to be left with you with the radius away from the center of the Earth squared. Okay, so we have an equation here in which we need to solve for this little x here. So how do we set this up? First of all, we know the value of the gravitational field strength. We need it 1/2 of 9.81. We also know the mass of the Earth. We also know the universal gravitational constant. We also know the radius of the Earth, but we have to be careful with this R value down here. So to rewrite this, it will look like this because we will have, we're going to have big G, mass of the Earth, and this R value is going to be the radius of the Earth plus that extra distance that we need above the Earth's surface. So we need to solve for this x, meaning we gotta rearrange this ugly looking equation. We're gonna have to multiply the bottom up, RE plus x squared. We're gonna multiply this ugly thing up. Okay, and this is gonna give us RE plus x, all of this squared, times gravity equals big G, and mass of the Earth, I'm going to divide both sides by the G value, which we know is 1/2 9.81. We're not going to substitute that one just quite yet. Okay, so this goes away. Okay, and we're left with RE plus X. All of this squared is equal to big G, big M, and the gravitational field. Taking the square root, this just becomes labor work for doing the algebra steps, okay? But, yeah, I'm gonna do it, okay? So this is going to give us RE plus X is going to be the square root of big G, big M over small g. Okay? So in fact, you know what? I'm just gonna be a little, and then, anyways, sorry, I'll continue. So then after you take the square root of whatever's on the other side, all you have to do is subtract it by the radius of the Earth to get the remaining distance from the surface of the Earth to the point of which the gravitational field is half of what you experience on the surface. Okay, so we finally can put in some numbers. G is going to be, so solving and plugging everything in, we get 6.67 times 10 to the power of negative 11. Mass of Earth is 5.97 times 10 to the power 24 kilograms. Okay, and all of that divided by the 1/2 of 9.81. Okay, and don't forget to subtract the radius of the Earth, which I'll do here, minus 6.38, I think, times 10 to the power of 6.37 times 10 to the power of 6 meters. Okay, so putting that all in the calculator, I get 2.64 times 10 to the power of 6. So round it up to what? 2 sig figs? That's going to be 2.6 times 10 to the power of 6. What is this? Oh, gravitational field strength. So you can either, oh, sorry, this is a distance in meters, of course, okay? Oh, and there it is. Oof, all right. Cool. Awesome. So that was example, what was it? 6? Example 7. Oh, example 5. You know what? I'm going to break it off into another video just because it's taking a little bit of time and just so you get a little break. So we'll end it right there. Next 2 videos will be example 6 and example 7. Thank you for watching. Fan Mom Physics signing out.